we discussed the last things about electromagnetic induction and alternating current rectification. Actually, we discussed
So we
some
did
past
questions. We did
questions.
questions.
We did questions.
Yeah.
We did questions. I remember all of the things that were there in the question. So yes, we did questions yesterday. Now, today we'll be starting quantum. Quantum is one way of looking at the world. Well, for example, if we consider physics as something as a subject, as a discipline, that physics can have two basic stacks in it. Number one is quantum. We want to see everything with as small particles, small discrete numbers, and other is considering everything as a continuous thing. For example, time and space can be considered as continuous in the theory of relativity. One way of looking at the world is with the Einstein's theory of relativity, and the other is as quantum. So just now, one second. Okay, I'm back. I'm back. Now, quantum is one way of looking at the world. Einstein's theory of relativity is another way of looking at the world, and they apparently in many cases they don't agree with one another. They are totally different. Theory of relativity does not believe in there is no space for gravity over there, because gravity is explained as bent in space because of mass. So in quantum, light is considered as a small particle. All electromagnetic waves are. So some things cannot be explained. For example, whether light is particle or light is wave, because we say it to fix the problem. It is like agreeing to disagree that light is particle as well as wave. But when we say light is wave, it cannot be particle, because particles cannot be wave. And when we say light is particle, they should not behave like waves. So it is not like they can be both. It is they're two opposite things, and we just believe because we don't know yet. So we agree to disagree. We just keep it for some future time future time and future intelligence, that we might be able to figure out whether light is one thing or the other or something else. So unluckily, we don't have theory of relativity in our syllabus. We don't have anything about relativity in A levels. We will only be discussing quantum. And let's start. The most important thing that we discuss in quantum is photon. What is photon? Photon is a discrete particle or a quantum particle of electromagnetic energy. Photon is a discrete packet of electromagnetic energy. And this is a very favorite question of examiner for A levels. He very commonly asks this question: what is photon? Now, electromagnetic spectrum. Electromagnetic spectrum consists of like it is a way of classifying electromagnetic waves. We apparently classify them on the basis of their wavelengths and frequencies, but actually they are classified on the basis of their manufacturing method. How do we produce them? Radio waves have the longest wavelength and lowest frequency. Gamma rays, they have more. They are the most energetic ones, and they have the smallest wavelength and highest frequency. Planck discovered that there's a relationship between the energy of a photon and its frequency. And they discovered that energy of a photon is directly proportional to its frequency. Energy and frequency are what? They are directly proportional. And when we convert this relationship into an equation, it becomes E equals to HF, where H is Planck constant. The value of Planck constant is 6.16 into 10 to the power minus 34 joule second. You don't need to remember that. Not at all. It will be given in data booklet, but believe me, after using it 3-4 times, you will remember it. Now, we already know C equals to F lambda, which is the formula for speed of light. And when we mix it
Sir,
with
just open please.
Like this,
Yeah.
like this. So speed of light is frequency times wavelength. And when we put this formula into E equals to HF formula, we get E equals to HC over lambda. Okay.
Sir,
Then
sorry to interrupt.
Yes.
ये सबसे right पे F ray क्या होता है? What's an F ray?
Oh, it is not an F ray. It is
It's a gamma. Okay.
gamma ray. Okay. Now,
Yeah, okay,
one very famous equation, even people who don't know physics, they never studied physics, they all sometimes quote this equation. That is E equals to mc square, where E is energy, m is mass, and c is speed of light. So we can also merge this equation into E equals to mc. We can merge E equals to mc square into E equals to hf. So first thing is you can see mc square equals to hf, and then we can do many kinds of mathematics, and then we have this wavelength formula, because mass into speed is momentum. So momentum, when Planck constant is divided with the momentum of any particle, it will give you an equivalent wavelength. Equivalent wavelength means if all that energy that that particle has, whose momentum we have, if all that energy is converted into a single photon, what will be the wavelength of that photon? Okay. So that wavelength is known as de Broglie's wavelength. And it means that if all the energy of a particle is converted into a single photon, the wavelength of that photon will be de Broglie's wavelength. So we have these formulas. E equals to HF, E equals to HC over lambda, T equals to F lambda, E equals to MC square, and lambda equals to H over P. Okay. All those formulas that are in boxes, they are important. You should remember them all. If somebody has to take a screenshot, do it now. No.
One sec, could you go back?
Done?
Yeah.
Good. Now, okay. Here's a job for you. Did you note all of the formulas? Now, let's start with the visible light. The least frequency that we can see is red. The highest frequency that we can see is violet. I have given you approximate wavelengths of all of them. All these numbers are in nanometers. Use these nanometers to find frequencies, and then use those frequencies to find the energy of every single, like, what is the energy of a single red photon? What is the energy of a single orange photon? What is the frequency of a single yellow photon? Once you get all the frequencies, use those frequencies to find energies. So energies, you can use that Planck formula, E equals to HF for that. The value of H is 6.16 to 10 to the power minus 34. Use that to find energies. And then you have to convert all the energies in electrovolts. And there is a formula on the right top corner of your screen right now. Energy in joule divided by E, which is elementary charge, gives you energy in electrovolt. And the value of E is given over there. Hurry up, complete this table.
पता नहीं इसलिए कहीं राउंडिंग का मसला आ गया कहीं अगर
Okay. Now, the wavelengths are given from 700 to 400. We converted them into frequency. For doing that, use lambda equals to C over F, or F equals to C over lambda. Then, after doing this, you can use E equals to HF for E, and then convert energy in joule to energy into electrovolt. So now what you have here is a different ranges of visible light. Most of you remember that the range of wavelength for visible light is from 400 to 700 nanometer. But now you should know that the range for frequency is 4.3 to 7.5 into 10 to the power 14 hertz. And of energy is 2.9 to 5.0 into 10 to the power minus 19 joules. In electrovolts, we can see from 1.8 electrovolt photon to 3.1 electrovolt photon. This is the visibility range of human eye. The same thing is explained here. Why do we need to do this? Answer is because sometimes question is given by the examiner, and the examiner says that find frequency of a photon, and there is some reaction going on, and there's a missing photon over there. So we have to investigate about it. Like, we need to first of all find that there is a photon, and then we have to find energy of a photon and use that to find frequency of a photon. And then at the end, examiner can ask you whether that photon that you were talking about, was that visible or not? How can we check? Now, either we convert whatever photon we have and find the wavelength of that photon, and then use that to fit within 700 and 400 nanometer, which is always a backup plan. But if you know the range of electrovolts, or range of energy, or range of the frequencies, you can directly find out whether the photon that you're talking about is within the visibility or not. Okay, that will make your life easy over there. Now, what are energy levels? Electron and photons have a very interdependent relation between them. they have a relationship where electrons can absorb photons. Electrons can absorb photon, and then electrons can emit photons. When electron absorbs photon, they become excited. They move from their equilibrium position to their excited position. Electrons, they go from their original position to their excited position. And this happens when electrons gain photon. Electron plus photon, that means electron and photon is kind of energetic electron. Okay. Then when there is an energetic electron, if we take energy out, electron can emit its energy in the form of a photon as well. Electron can absorb photon, electron can emit photon, they can produce photon. How do they produce photon? By releasing their energy. Whenever electron releases energy, it releases energy in the form of a photon. So what happens when electron releases that energy? It becomes de-excited, it becomes relaxed, and it comes back to its original position. So here is a kind of a relationship between electron and photon. Electrons can, one electron can adopt only one photon at a time. When electron adopts photon, it becomes excited and moves to high energy level instantly. When electron releases photon, it comes back to the de-excited state instantaneously or instantly. And instantly word is never used so literally than here. When we say instantly, it means without using any bit of time, any fraction of time. They go from one energy level to another energy level without consuming any time. There's no time spent when electron goes from one energy level to another energy level, because electron is not passing through any intermediate situation. When electron is, for example, let's say the ground state, electron is at the ground state over here, and it absorbs a photon. This photon makes it energetic. It is not like electron has to travel all this way and get there. Because if electron is traveling, it means it was some time found over here. It was some time found over there. So that is not possible. Electron can either exist at O, or it can exist at 1. Okay, there's no in-between values. So what happens is when electron absorbs that photon, it stops existing in the ground state and it starts to exist over there. So it is very much like teleportation. So electron does not travel from one energy level to another energy level. It disappears from one energy level and starts appearing in another energy level at the same time. So this is what is meant by term instantly in this scenario. Okay. Tomorrow we will resume from the same point.
Okay, sir.